So, welcome to table number 3. It's the one before the last. So you're almost there, guys. Like almost free. Uh, I can almost smell the shrimp. I don't know if there's a shrimp. Okay, so the title of the table today is The Future of Privacy. Of course, quite auspicious. Are FHE, MPC, and differential privacy the solution? The answer is, I don't know. They know. So I have a small statement to make before we start to introduce the table. So this is the third table. In here, we will discuss the challenges and realities for MPC, FHE, and differential privacy, and what holds beyond. Yeah. So we have been promised in this room and have been preached for years about the powers of these pets and how the startups working on these technologies have promised relevance and impact. FHE will be everywhere, from my healthcare to my Instagram posts. So they say, all that they say, is it true or is just hype? Yeah, we have been promised a revolution in AI, but in a world that rewards speed and accuracy, we have been blessed with a paradox encompassing the need of training these models with robust security and privacy, and with keys that measure in gigabytes and the limitations of scaling MPC, it is really feasible for us to use it on our daily devices. So here we stand in what initially looked like a trade-off, now looking more like a Mexican standoff, with a real possibility of giving up privacy completely in AI. So is differential privacy actually the way to go? And differential privacy can allow us to break free of cryptography? Like, we don't know. The question remains, and the question is for the panelists to solve today. So we have here three incredible people. So if you can move, yes. So we have Chung Hee, who comes from the University of Korea, and he is also the CEO of Cryptolab. We have Emiliano de Cristofaro, who comes from UC Riverside. I'm sure people in Santa Barbara really appreciate that. And Christopher Patton, who comes from Lautfer. Okay, so I will invite our three panelists to introduce themselves, so like they can explain what they do, what's their focus of their work, and answer these four simple questions. Okay, what is privacy for them? What's what is on their personal pipeline in the companies that they work for? What is being done about privacy? What do they think are the main costs and considerations that we have to take into account when we deploy FHE, MPC, or differential privacy? And the real question that brought us all here from far distant parts of the world, like, are these futuristic tools? Are they today tools? Or are just academia pipe dreams? So we answer, they will help us answering all of this. So maybe we can start with Professor Chan He, because he has some slides to show us. Or just I introduce the slide? No, you just introduce your slide, and then maybe you can give us some feedback on the questions that I. Huh? Yeah, your introduction, and then after that, the slide. So yeah, slide. Yeah, so the clicker. Use the green. There you go.
Hello, I'm Chung Hee Chen, professor of mathematics in Seoul National University and founder of HE startup Cryptolab. Let me briefly introduce some recent development of HE and then its application to encrypt the AI. So what are the challenges in HE? So three of them. The first one is memory problem. Second one is the heavy computation. So memory problem includes some ciphertext size problem and then key evaluation key problem. And then heavy computation comes from linear operation, nonlinear layer and also from bootstrapping. But those problems are now being solved. Like for example, ciphertext messages, plain text ciphertext ratio was regarded as 1,000 times, but later becomes 50 times. Now it can be reduced into 1.2 when you are using bootstrapping techniques. And then heavy memory pressure can be also solved by more efficient uh, key management. So we have several work, and then also heavy computation problem can be solved for linear operations. We have some papers in this crypto about plain text, ciphertext, matrix multiplication. Surprisingly, it's only 3 times slower than plain text matrix multiplications. And also we have some result in convolution, accelerating convolution in CCS this year. And for nonlinear layers, several works like tuple CKKS and the softmax. And then to speed up bootstrapping, meta BTS is very important. And then we have discrete CKKS papers in this Eurocrypt. But so now it's more problem comes from usability or regulations and social recognition rather than the technical problems, I think. So we are facing the third problems now. So due to those works, we can speed up the homomorphic encryption performance. For example, if the best one from the open source FHE, you can enjoy the bootstrapping like 100 seconds. But if you use GPU, in our implementation shows 77 milliseconds. It's like more than 1,000 times faster. If you are using this one, we can apply this one to end-to-end encryption with fully homomorphic encryption. That is, even with some computation in the middle, we can use end-to-end encryption. So without any decryption, you can encrypt the messages and do the computation, and then without decryption, you can decrypt and then get the result. So this is a implementation result. HETA, it's outsourced AI training. So when you want to distinguish the user cars and from the military vehicles from the user vehicles, we would like to train the fine-tune the model with the encrypted military vehicles. It takes only several minutes and 2 hours. And then model inference is just 0.3. You may wonder, how can we implement large language model on encrypted data? We implemented this one. And then this is the Llama 2 7 billion model. Number of decoders is 32, and then sequence length is 128. In that case, if we encrypt the queries and send to the server without decryption, the model inference is done, and it takes 2.7 minutes to produce the first token. It's the second token and third tokens are faster. It's still slow, but in homomorphic encryption, it's a computation. If you use more devices, you can speed up. Also, you can think about the fine tuning. So usually in inference, you think the real time inference is more important, but some application does not require real time implementation. For example, transcription. If you use this model for taking note of medical doctor's speech, then in that case, it's a kind of FAQ or Q&A style application is possible. Also, it can be used for the fine tuning of the LLM model with encrypted data. In that case, we use only several number of encrypted data to fine tune the model. So it's quite practical. So I think the homomorphic encryption already is a good tool in many applications, and also it can be accelerate more and more. For example, in history, we accelerate 8 times a year. So next year you can expect that 8 times more faster implementation result. So even LLM will be practical in near future. Yeah, thank you. This is the summary.
Yeah, so I can keep this one. Hello. Yes. So I guess the outtake is that the professor believes FHE is practical. Okay. So Christopher, maybe he can help us now.
Yeah. Oh, it is on, right? Yeah. Okay, I didn't prepare slides. I didn't know that was the assignment, but I'll just say a little bit about what I do. So I work at Cloudflare. I'm on the Cloudflare research team. Broadly speaking, what our team does is look at where we want the internet to be in 3 to 5 years, and then we take actions to move the internet in the direction we think it should go. I work mostly on privacy projects. I'm the thing, I think the reason I was invited here today is I'm working on this a class of problems we call privacy preserving measurement. So broadly speaking, tech companies like Cloudflare want to know, would like to have insights into user experience and user behavior in order to make services work better for people. So this is things like bugs, UX issues, performance issues, attack vectors, and things like that. Things that we want like aggregate insights into. And of course, training machine learning models is also a problem I would stick into that space. So what I've been working on for the last few years is to bring a few lightweight tools from MPC to bear on this class of problems. So we are standardizing some very simple things through IETF to make them more broadly useful and to provide a deployment path for them. So this thing includes things like everything we're doing is basically just secret sharing, largely additive secret sharing, and then we have distributed ZKPs that for input validation, and we can do function secret sharing and stuff like that. So yeah, the objective is this stuff is really practical. It's very efficient, and we want to make it as broadly available to as many organizations as we can. I like to think of my job as, turning fancy crypto into boring crypto. We want engineers to be able to use these systems without having too many foot guns to get in their way. So yeah, that's a little bit about me. I'm not an MPC expert. I'd say there's a corner of MPC that I know really well. And that's it.
Hi, thanks. So I also didn't prepare slides, so that's 2 to 1. So yeah, my name is Emiliano Di Cristofaro. I'm a professor at UC Riverside. I was in London for 10 years and just moved back to California last summer. So yeah, I'm kind of like a recovering cryptographer, I would say. So I work on privacy, and I used to actually do sort of privacy-oriented cryptography with a really big focus on efficiency. So a little bit more on the system sides of things. So I've helped design privacy-preserving protocols like private set intersection or deployments of homomorphic encryption kind of primitives in a number of applications. I don't do as much anymore. So I still do privacy, but I've been more focused on privacy in machine learning. So some work a little bit on homomorphic encryption, but more on understanding leakage from privacy leakage from machine learning models. So looking at attacks, and for like on the defense side, I would say mostly using differential privacy more than MPC or FHE. So we've been working on sort of deployment of privacy enhancing technologies for things like federated learning and so on. So I've been doing a lot of work on that. And you know, to say like maybe the reason I've been invited here, if I can speculate, is okay, maybe for this kind of work that I've done, but also I've been relatively vocal in and not particularly buying into the cryptocurrencies and blockchains hype. And so you know, I kind of really trying to look at deployments of cryptography for privacy that are not for you know blockchain cryptocurrency related projects. So really happy to learn more about these projects today.
So speculate away. So not a problem on that. So I have a question for all of you three. What do you think about differential privacy, MPC, and FHE at this moment in time? Do you think these are realistic tools, or do you think they are just a pipe dream that some mathematicians are cooking in labs? So whoever wants to.
To me, the uh, FHE should play a central role in this area. So because it should encrypt all the basic data, and then the role of MPC in this in this style, it's like for example, it's more minor in the sense that it can be used to provide a threshold cryptography or multi-party so like FHE can be a central role, can play a central role, and then MPC can help in some part, threshold part, also multi-party part, and also when we publish the result after result of the functions, why we can use the differential privacy. You know, the FHE can protect the computation on encrypted data, but when the result is decrypted and published, the FHE can not do anything. So in that case, differential privacy is good. Like we apply the differential privacy to the result and publish this one. So all three tools can be used to provide some good security in some applications. But there, more operations should be done in FHE. That's my thought.
So I think there's a tendency among people in our community to apply the tool they know the best to more and more problems. And I think this is natural because it's what you understand. It's kind of the lens through which you view the world. But I think every problem, every privacy problem, you have to kind of take a holistic approach to and figure out, start with first principles. What is your threat model? What is the thing? What is it you're trying to actually achieve? And then figure out what tools are like practical for the problem. So I don't think FHE is going to solve every problem. I don't think MPC is going to solve every problem. I don't think DP is going to solve every problem. I think your many applications are going to want a mix of 2 of 3 or maybe 3 of 3. I think there's a little bit too much focus on and perhaps too much hype around the generalization of the thing. So FHE or general purpose MPC are not tools you should always reach to first. You want to, usually there is going to be something more tailored to your problem that is going to scale much better.
Yeah, I really agree. So I think it's neither sort of a pipe dream or, you know, something destined to remain in sort of a mathematical closet. I think that we have a tendency of overhyping sometimes, and this is not specific just to crypto or privacy. We see that with all sort of technologies or sort of new things, right? And so I think we have to be honest with what we can do with these privacy enhancing tools. So obviously stating that we have these sort of magical general purpose tools that can solve any problems is not realistic, right? So we need to, as Chris was saying, we need to understand what tool and can work in certain settings and applications. But there is going to be inherently situations where we actually cannot guarantee privacy, right? So, I mean, just give you a stupid example with respect to differential privacy. If you want to, release statistics and use statistics to do, I don't know, anomaly detection or something, right? So, in order to have privacy, you have to, in order to satisfy differential privacy, you need to sort of kill the outliers, right? So obviously, that's not very conducive to, performing sort of anomaly detection, right? I mean, this is very oversimplified example. So we have, but I hope it sort of shows that there are inherently limitations as to what we can do and what we cannot do, right? And but I think that there is, I'm more optimistic than saying everything is limited. So because there is so much effort actually in real world applications that now integrate these privacy enhancing tools, certainly a lot more than 15 years ago when I started working on these problems. And there's a lot of companies that invest significant amount of money building tools and communities and open sourcing, like funding sort of projects and so on. And I sort of find it interesting too that sometimes when this happens, then like us academics are sort of suspicious sometimes. They say, "Oh, privacy washing," right? So they're trying to, pretend that they care about privacy so that we entrust them with more data they can spy on us even more. I think that it's not particularly useful to generalize, of course, but I'm mildly optimistic.
Well, I have a question related to that because privacy washing is thrown around a lot these days, especially with the security models that we sometimes see on the papers. So I wonder, what do you think about the security models that we study, right? Like, for instance, machine learning on MPC and FHE, there is a big focus on semi-honest security, right? Whereas what is really needed in the industry, do they align well? Like, Christopher?
Yeah, I do have a strong opinion about this actually. Yeah, I mean, we do care about malicious security. I think though, I think though there needs to be a separation between, it's useful sometimes to have a separation between what is like the actual like informal security goal versus like, because the way MPC is traditionally defined, like malicious security means like it asks whether the attacker can cause the honest parties to compute something other than what they would compute in the absence of the adversary. And that implies both privacy and correctness. Correctness is just like less important, at least for the applications that we're looking at right now. It'd be nice to have both, but not at any cost. So I think I'd say like yeah, but for privacy, your attacker is your attacker, right? Like you want to take the strongest threat model you can.
Yeah, just very quickly, I agree. So I think that's again, we go back to what we were discussing before, that we really need to understand the specific setting, the specific application, the specific threat model that we are operating in. So it's not particularly elegant and great to say, okay, we need to really grind a lot and do a lot of engineering work, and but that applies to the threat model as well. So we need to understand whether that threat model makes sense in that specific setting or not in general.
So just to do a small, yes.
Hi, so I have very little experience with these topics, and I know a little bit about full homomorphic encryption and MPC, but I don't know about differential privacy. And I can also imagine an application where you really need the fully homomorphic encryption, and one when you really need the MPC. For me, it's hard to think about in something that where you need differential privacy, like and the two solution don't work. So could you first explain a little bit what is the intuition between differential privacy, and if you can tell an application where you really need differential privacy and not multi-party computation or FEG, whoever is it.
So I'd say like I'd say what's nice about differential privacy is that it's a formal definition of privacy. So the definition of MPC or the definition of FHE speaks to the functionality, and what like the attacker learns at the end of the day is like what you intended to compute. And what you intended to compute is like could leak a lot of information. So if you're just aggregating some telemetry, like Emiliano said, like for anomaly detection, you want the things that differential that the things that would stick out that would actually like violate differential privacy. So like I guess the way I answer that question is like neither is sufficient on their own. Depending on what you're trying to do, you might want both. And in fact, MPC is quite compatible with many techniques for differential privacy.
So I have a specific question on that maybe Emiliano can help us out. Like here in the US, I understood that the census uses differential privacy, right?
Yeah.
Like, but they don't use any other bets to protect the information of the queries, right? Like just differential privacy.
Yeah, so I think the easiest way to differentiate between MPC, let's say, and differential privacy is that they provide different functionalities. So typically we say for MPC, we try to protect the input of a computation, and for differential privacy, protect the output of the computation. So that's why sometimes you combine the two. So you can jointly compute a function privately using MPC, but then you disclose the output of that function. So differential privacy will bound the information disclosure that stems from that output, for instance. So it's kind of like they provide different functionalities, right? Yeah, with the census, yeah. So that's very interesting. I think it's been obviously a very great deployment in that it affects millions of people on a real world application. And there's also been an interesting sort of research challenge because we're still, learning about potentially some attacks and some limitations, when it comes to, maybe the disparate impacts that differentially private noise might have on like minorities, underrepresented classes, right? So I think I'm very excited about that. But to answer your question, yeah, so that's the assumption is that, the queries are not private per se, right? So you don't hide the query, but you want to reduce to bound the information leakage that the queries reveal about individuals. So you add noise in a way that you satisfy differential privacy. So there is no MPC yet. Okay.
Well, thank you guys. So to keep on the topic of correctness, I have a question for Professor Shunhee. So we have seen the rise of companies like Crypto Labs, like Sama, like Duality. Are they actually focusing on the correct security models? They are actually trying to solve the security models that the industry demands, or you see uh, diverges from what the market actually is in need?
Yeah, definitely the FH cannot solve all the security problems. So let's separate two scenarios. One scenario, usually we say like a decryption for myself. If FH is used for outsourced computation, the security model is quite satisfactory. That is, we encrypt our input or our query for myself, and then send the ciphertext to the server to the computation and get back the result. and then it's decrypted by the owner. In that case, since the decryption key is owned by the data owner only, this is quite secure. But here, it does not guarantee the correctness of the computation. So because to guarantee the correctness, we need some verifiable computation technique. But without this, the security is still valid in this scenario. But we have other scenarios like federated learning scenario or aggregated computations. In that case, the encryptors can be different from the decryptors. And then also decryptors can be several parties. In the case, the security models are quite complicated, and we need to use more techniques than FHE, like differential privacy can secure the output result, and also MPC can be used for the key sharing, secret sharing, something like this. So from this point, this encrypted AI or machine learning is quite good application of FHE. Here, FHE is itself can provide some security aspect for this one because it's just outsourced computation.
So a question for the three of you. If somebody has a question, please go ahead. Nobody? No, just me? Okay. So what I often read is that the fact that these models, the security models on the papers, they are soft, let's say, call it soft, versus what we might see in industry, like the need of verifiable computation and things like that. They can be breached via reputation systems and like legal repercussions if somebody cheats, liability. Are these assumptions real, do you think, or you think industry needs more than these kind of reassurances? And if these reassurances are enough, like, should we put something in place to be sure that these reassurances are delivering?
I think it really depends on what you're doing. Like you have to be really specific about what the data is that you're computing on. I mean, if it's browser telemetry, it's kind of low stakes, and you have two parties, and the assumption is that one is not colluding. If all of that party can do, if it's cheating, is break correctness, then it might not be so bad. On the other hand, if you're doing I guess what I think of as the classic MPC problem is the 2 millionaire problems, right? Like 2 millionaires get together and they want to find out which one is richer. That might be high stakes. I don't know. And you might want you might want fully malicious security there. Yeah, I just think it really depends.
So on machine learning, Emiliano, do you think that there are things that research is not actually targeting in the way that the industry would actually need? I see a lot of works about how to correctly use synthetic data mixed with differential privacy. I also have checked some of your papers saying that there are many possible attacks to that kind of line of work. So I wonder, what's real?
Right. I mean, synthetic data is a good example of, let's say, I think the disconnect, I would say, between sort of commercial applications and sort of, research, not just in industry, sorry, not just in academia, but also in industry. So if you look at, I have consulted, actually, I've done some work with some companies in the space, and when you talk to customers, not just the synthetic data providers, also the customers. So there is really a limited understanding of privacy and the privacy challenges. And I think that's not entirely surprising because that's also how it used to be in many other sort of settings of privacy, and then things slowly got a little bit better. I mean, I am old enough to remember when like companies were saying, we cannot do HTTPS, it's costs too much. And now, nobody does not do HTTPS, right? So, but there is that sort of really, there's a big gap between, you talk about fully malicious security or things like that. So, I mean, in that space, people don't want differential privacy, don't care about any sort of privacy definitions. They just want, utility or fidelity or something like that. And so they sort of reason about privacy as in terms of sort of metrics, like as long as the data, the synthetic data is not too similar to the real data, then it's deemed to be private, right? So basically, there's assumption that there is no sort of a sophisticated attacks, there is no auxiliary knowledge available to the attack, and as long as you sign some sort of legal document saying that I'm not trying to break privacy, and if I do, like, sue me, then it's fine, right? So I'm not sort of laughing it off. I think that there is some commercial reasons behind this, and this is sort of we also have to understand sometimes the use of the synthetic data is not necessary to disclose it and put it on the internet, but it is even sometimes these products are used within the same company but just across two separate sort of entities within that same company that for regulatory purposes or for internal regulations that say they cannot actually see the data in the clear, so that then they generate this data. So there is a big disconnect. To answer your question, there is a big disconnect, and it's also sometimes maybe it's, as researcher we need to do a better job at sort of explaining and educating and understanding the requirements and so on. So again, we go back to the initial things that when we have tools and problems and solutions, right? So we tend to think, okay, maybe 80% is the idea and 20% is the execution, but really it's not. So I think in many cases, maybe the idea is 20% and the execution is 80%. So we need to really be specific to the specific setting and application.
So I hear a lot about execution and settings and like less about the cryptographic aspects of the things. So I wonder, when you think about deployments, what are the biggest challenges that you typically have to overcome? Whoever wants to answer the question, maybe for deployment, yeah. So what are the biggest challenges that you face when you try to deploy solutions?
Can I comment about the security more about this?
Sure.
Questions. Like I think I want to point out that we should change our perspective. Like when we are think about when we use encryptions or HE for the security purpose, the indistinguishability is the best goal. We should achieve the goal. But when we are using our crypto techniques for privacy, the situation is different. In privacy, no information is zero information leakage is hard to define. So like so in some information should be revealed on purpose. In that case, I think we have three goals, like indistinguishability, then data protection, and then secret key protection. Definitely, secret key protection is much more important because one secret key can be shared, can be used to encrypt many data. So if some information, even a small bit of information or secret key is revealed, it's dangerous. So this is super important. For the data protection, sometimes some data can be revealed, or should be revealed, or it's hard to protect. So, but here I don't know how to measure the risk of the data breaches here. I think we need more proper measurement for measure uh, definition kind of in these areas. But still, so that's a different point from the security and privacy. And then indistinguishability. So yeah, we uh, as a theory, as a cryptographer, as a theorist, we have we like to explore what, how we achieve the indistinguishability in these FH areas, but somewhat limited. Its usefulness is somewhat limited. So, but still we can say, oh, it's broken if it does not satisfy in this indistinguishability. So we should separate all three goals, and then it's better to explore separately. I think this is very important things. I think, yeah.
I think that's a good outlook. You know, try to solve problems individually and try to combine it. So coming back to the challenges, maybe Christopher can help us with his view.
Yeah, so I'd say like I think 80-20 is probably the way to split it, but like I agree, like 20% really is the idea. And there's a lot of ways that the 80% manifests. From my own experience, like we're basically have been working a few years to like bring to the world there's like a handful of papers, like a few recent papers, all of which are like really practical and very like oriented towards like this is something that someone can deploy quickly and is really efficient. And that's necessary. So I think like kind of stepping back to the broader question of this workshop, I think the academia is providing like necessary innovation, but it lacks direction and it lacks like more close interaction with people who are actually going to be using this. So I think the deployment challenges are like at least for MPC, it's not the crypto that's hard, it's the distributed building the system around it. Like you are building a massive distributed system, and if the MPC is like very bandwidth heavy, which a lot of like general purpose MPC is extremely bandwidth heavy, as is FHE, you have to figure out how you're going to handle that. And it's not easy. But I would say an even bigger question is like education. So your like I said, my job basically is educating. A lot of my job is educating engineers at my company about how to use this cryptography and how to build the system around it and what assumptions they can make. And like explaining like what is the limit of like what MPC can and can't do, and same thing for FHE, the same thing for differential privacy. So yeah, I'd say we can't ignore the systems problem. We can't ignore, we have to think of ourselves as educators. And yeah, I think that's two things I'd bring up. Thoughts?
I strongly agree about the problem to educate the engineers. Yeah, like I wrote here, the usability, regulations, social recognition are more serious problem than technical development. So when even though someone wants to use uh, those HE technique in industry, even though he understand fully understand the technology, it's hard for him to persuade or explain this technology to his boss. And then his boss has another problem to explain why we should use this HE or MPC or differential privacy, because because it suffers lack of social recognition. So finally, eventually, the social recognition is the bottleneck to be for deploying those crypto techniques in industry, I think.
So now that we are moving a little bit on the lines of usability, I have, we don't have much time either. So I have a couple of questions about adoption. Okay. So what do you think is the adequate strategy for adoption? What can we do? Is it, for instance, standardization? Is it, for instance, improving the tools that are available? Uh, Legal requirements on the system? More regulations? What do we add to the equation for fostering adoption?
I mean, again, it sort of depends on the case by cases, but I think one good way to look at it is to look at the success stories and see what has worked. So especially when it comes to, let's say, user facing privacy, right? So no, maybe not necessarily, privacy or confidentiality of sort of company or like data related to companies or let's say population level, right? So if you think about like privacy tools that have been deployed successfully over the past few years, like I think the first thing that comes into mind is let's say is end-to-end encryption, right? So we went from PGP and GPG and the fact that it was extremely hard to use and not you know very used to the fact that now everybody, I think 99% of smartphone users do use some form of end-to-end encryption, either through WhatsApp or iMessage and so on, right? So I think there's a couple of things that have worked in that space. One is to make the process sort of almost oblivious to the user, like transparent to the user. So we don't, I think users are not really asked to do anything. I mean, if you want, you can verify the fingerprints. There is some degree of understanding when you say the security code has changed, or understanding what the different messages mean. But overall, you're not required to generate keys. You're not required to have to use kind of like 64 character passwords. You don't have to revoke keys, right? So I think that's one big lesson there, is that do not put the burden of privacy onto the users, right? And the second one, I think, has been sort of like a community effort, like standardization that has come across. So there were, I mean, ultimately the protocols were there, like it was based on OTR and other simple cryptographic primitives that have been proposed by researchers many years ago. But then again, there was a lot of efforts in execution, in creating tools that first went into Signal and then they were ported into WhatsApp, right? So, and that also sort of created, set the standard, right? So, basically, if you are one of these big companies, you cannot be the only one that doesn't do end-to-end encryption, right? So, but again, there is like a community built around it. Is open source tools. There is transparency in the technology. There is ways to verify implementation, so on. And there is many other examples. Maybe Chris can also talk about the stuff that came out of Cloudflare, for instance, right? So I think let's look at what has worked, so and what hasn't worked, right? So I think, for instance, the fact that you create communities and even let's say with federated learning, right? So there is lots of limitations and there is lots of hype and there is a lot of criticism that is valid. But ultimately, I think it was a great thing that, let's say, Google created a community around it. So everything is open source. Everything is, there is a community that is supported through libraries, to toolkits, through funding, through events, through workshops, and so on. And so then it also created a tool that has been used in other settings by other companies. So let's look at what has worked.
Oh, no.
Oh.
I don't know what spot you put me on, though. I have to think about what you just said. Uh, um, yeah, I mean, I think I don't. So I think end-to-end encryption is actually like it suffered from a problem of lack of standardization. So in fact, like a lot of these tools, so like let's say Signal, WhatsApp versus iMessage, they're all basically doing the same thing, but they're subtly different and they don't interoperate. And that's actually a problem that IETF is trying to solve right now. There's this working group called MIMI, and it's going like, it's not going great. There's a lot of different perspectives on the problem. A related thing is this key transparency problem, where if someone, changes their phone, like right now, the way end-to-end encryption works, it's like trust on first use. I get I see someone show up, and if they have a fresh public key, I don't know who they are. And key transparency is meant to kind of link the new key to the old key so that you can, and every company wants to do this, but they all are doing it in different ways. And so I actually think that right now, more standardization would be better. Standardization is also hard, but I think the value of standardization is that once you've achieved it, you, in theory, have something that anyone can go implement. All they have to go do is read the RFC, and they don't have to. They don't. That's when crypto is boring. And really, I think that's what all of our goals should be. Is fancy crypto is cool because the math is cool, because it's fun to implement, and the things you can do with it are amazing and kind of magical. But we have to turn that magic into bits. So yeah, I don't know, like standardization for my own little corner of cryptography. I think not my corner, our corner. I think standardization is necessary. We have an interop question, and also like it it needs to be it needs to be simple and easy to use, and like you said, zero cost for users. So how do we do that? Yeah, I don't know. We're figuring it out.
So I have a question in this topic for the professor before we move, because the last question of the session, it's on usability, and it was given to me to ask at this event. So CKKS is patented. So do you think that's gonna hurt the apto- the ability of the scheme to be adopted? It's gonna hinder how easy it's gonna be adopted.
I don't know. So your question is, so yeah, repeat. I mean,
So CKKS is patented,
yeah.
right? So do you think that's gonna deter implementers to adopt CKKS? So that's the question.
Oh, so I don't know. So, but you know, if this scheme is standardized, it should follow the rule, like for example, brand or friend. So it should not be the bottleneck to be implemented, I think. Yeah.
Okay, fair enough. So thank you so much, guys. So do we have questions from our dear assistants? No? Okay, so I guess the question remains. I still don't know what I'm gonna use to encrypt the pictures of my dog. Maybe BGP or turbo speeds or functional encryption. Whatever it is, I hope that it aligns with the needs of the industry. And thank you so much for all your amazing responses. They were really appreciated, and thank you for coming.